Okay, everybody, welcome to the second afternoon session today. We have Ben Davis telling us about growing a joyful code base from legacy code. Let's welcome him.
Hey. Super excited to be here. What a great WWDC it's been, hey? Woo! Yeah, cool. So I'm going to start off with, who am I? My name's Ben. Here's a couple of pictures of me, and this one's not me, this one's my dog, Jasper. So I've been developing iOS for a while now, since iOS 4 is when I really started getting into it. Professionally, since around iOS 6, so I had to deal with the whole 6 to 7 transition. That was a nightmare. And in that time, I've written a lot of really terrible code, really terrible code. Colleagues of mine are in the audience who can validate that. And I've also seen lots of different terrible code, and I hope that's given me a little bit of experience that I'm going to be basing my talk on today. I've also worked in small teams. I've been a leader of a team of 5. I've also done remote contracting, where I've dipped in and out of all kinds of different code bases. And I'm currently working in a small health tech startup in London called Control Group. Control Group is currently working on an app called Fora Health. Fora Health aims to assist healthcare conversations. It has a chatbot interface, which helps patients track their symptoms, remind them to take medicine, has cognition tests, medically significant surveys, data visualization, that sort of thing. And the idea is that it's going to help them have better conversations with their doctors when they actually come to their consultations. And we also aid in healthcare research studies by providing clinicians with data from participating patients. But enough about me. We're going to talk about growing a joyful code base, and specifically from legacy code. So I just want to start off with, what do I mean when I talk about legacy code? Because strictly, it just means code you've inherited from someone else. But generally, in the developer community, we know it to be a lot more than that. Legacy code is this phrase that probably gives you this kind of uncomfortable feeling inside. Oh, no, not legacy code, no. I like to think that it's a combination of code that we just don't want to touch and code that's hard to change. And there's various reasons why that might be true. One reason, and this is quite core to a lot of the talk, is if it's not got tests. If it's not got tests, it's going to be really hard to change because we can't validate that what we're doing isn't changing the final behavior of that code. Michael Feathers, in his book, Working Effectively with Legacy Code, and that's a book I'm going to quote quite a few times in this talk, so I apologize for the repetition in advance, but he describes legacy code as simply being code without tests. And he gets quite a lot of grief for this because, what about clean code? Isn't that really important too? Well, yeah, clean code's important, but without tests, you don't really have any confidence when you change it, and you can't validate that actually it's doing what it's supposed to be doing in the first place. Code without tests is also likely to be non-modular because when you write tests, it really forces you to lay out your responsibilities in individual units that are easy to test. And adding tests forces your code to be more modular, provides documentation and examples of how you're going to use that code, and gives you the confidence to change it. I'm going to be talking more about testing a bit later. And generally, I'm going to be talking about making code easier to test and making it not legacy code as kind of synonyms of one another. So I recently moved into a new flat in London. And this was my garden when I first moved in. I thought it made a great metaphor for legacy code. There is just so much mess here. I don't want to touch it. I didn't want to go into it. There's this bindweed that's kind of wrapped itself around other plants and tangled itself in there. I don't understand which part of this is supposed to be the plant and which part's supposed to be the weed. And what's that pot doing there in the middle of the bed? It just makes no sense. So I want to talk about growing a joyful code base. So as I've just said, legacy code, we're all likely to come across legacy code in our careers. Probably many of us are working with legacy code today. And it might be code that we've written ourselves. It might be code that we've adopted from other people. Sometimes it just happens by mistake. And it's frustrating. Have you ever pulled your hair out because you just can't figure out how to get this one little bit of functionality in? It should be easy, but it's not. Well, you might consider starting again. you know, this has just become so hard to work with, screw it. It'll be easier if we just write it again, right? Well, greenfield projects can be like really nice to work with, but I'm going to be talking about an alternative to that approach, because often when you start a new project, you end up making the same mistakes you did last time, and the code ends up descending into legacy code anyway. And I've specifically used the word growing because it's something that's going to take time, a lot of care, a lot of patience, and it's similar to kind of growing a garden. That's not what I did with my front garden. I just ripped out everything and just planted new plants. The issue is that probably next year it's going to be the same weeded mess that I came to when I first moved into the flat. When you start from scratch, you often have to build it in a rush because you already have a product. Maybe that product's already out in the App Store, and you need to be able to catch up with that again before you can even start working on it, like adding new features. And that rush is going to cause the code to end up with bad mistakes again. Another thing is you lose all the information that was coded into your existing app. Like maybe there was all of these like niche edge cases you've thought of. Maybe there was this extra functionality that you'd forgotten even existed. And when you start again, you lose all of that. If you're a refactor, you can build your new features alongside that existing code. You don't lose any of that existing information. And the difference between starting from scratch and refactoring is that as you refactor, your code is going to gradually get better. Whereas if you start from scratch, it's going to start off as this beautiful design that you've come up with in your mind when you were planning it, and it's going to slowly descend into chaos again. I think I'd much rather be working on code that's getting better than getting worse. So a great developer that I'm working with at the moment, he once said that he was Marie Kondoing his code base, tidying it up. Marie Kondo's this Japanese organizing consultant who organizes and tidies homes and spaces. And there was a great talk earlier in this week by Ferren who talked exactly about the parallels between Marie Kondo's KonMari tidying approach and organizing your code, and I highly recommend it. It was really good. She also talks about possessions which spark joy, and I want to encourage us to try and get code that also sparks joy. I really want to be able to pick up that piece of code that I was working on before and go, yeah, that's great to use. I know exactly how that works. It makes total sense. I can read it. It's covered in tests. I can change it however I want. It's just great. Think about some of the Apple APIs that they've announced recently, like Swift UI, table view collection view, differable data sources. This is stuff that I'm really excited to work with, and they've really thought this through and come up with beautiful interfaces. So today I'm going to talk about some bad code smells in iOS apps. And I'm going to talk about sort of 4 key areas. A lot of the content of this talk is probably going to be quite simple. I mean, everyone's heard of the issues of massive view controllers. People know that there are dangers in singletons, that sort of thing. So maybe if you're a very experienced developer here, this is going to feel like a bit of a mantra. I'm going to be nailing in behaviors that everyone probably already knows, and I'm going to emphasize that. So we're going to start with massive view controllers. So view controllers play a really central role in so many of our apps. I'm just going to quote something that I read from John Sundell's post recently on extracting view controllers, because I thought extracting view controller actions, because I thought he summarized it really well. View controllers tend to play a very central part in most apps built for Apple's platforms. They manage key aspects of our UI, provide a bridge to system functionality like device orientation and status bar appearance, and often respond to user interactions like button taps and text input. Since they have such a key role, it's therefore not that surprising that many view controllers end up suffering from the common massive view controller problem, when they end up taking on too much responsibility, resulting in lots of intertwined logic, often mixed with view and layout code. And I'm sure most of us here have seen that sort of thing happen before. So we want to start cleaning it. So there's many ways to tackle legacy code. And I'm going to, again, refer to Michael Feather's book, Working Effectively with Legacy Code, where there's a whole appendix of different ways of refactoring code. But I think a lot of it is to do with extracting components. When you extract components, they have less responsibility. That makes them easier to reason about, easier to understand, and easier to test. And like I said before, easier to test is less bad design. When you take out components, the components can be tested more easily. As you bring them out, you can break off dependencies, making it easier to mock behavior around it, and you get better coverage, and it forces your implementation to be more modular and minimal. On top of that, once you've taken out that component, it can then be mocked itself in the original class that you were breaking apart, making that easier to test. On top of that, we're going to be developing our software architecture more organically. I mean, there's so many good mobile architecture designs out there. People hear the acronyms MVVN, Viper, MVC, MVP, RIBs, etc. all the time. And sometimes just jumping from a legacy code base to some huge, well-thought-out architecture is a really big and long process. If you're extracting out components that have common functionality, you're organically growing your own architecture, and I think that's a really good way to do it. So when talking about extracting components, I'd be wrong if I didn't mention inheritance and composition. There are times when inheritance makes most sense. For example, if you've got some generic logic that's going to be shared by one particular category of class, you've always got to think about that semantic if it is a something as opposed to has a something. One advantage of composition, for example, particularly when breaking down view controllers, is that the super class that you're going to be putting that common functionality in has direct access to all of the view controller methods. So sometimes that's a really good thing to do. But I'd say that generally, if you're using inheritance, it's only ever for code that's going to be shared a lot of times, because if it's something that's a bit more bespoke, it's more likely going to be better as a component of your specific implementation. Composition tends to give you more flexibility, and that's because you can add multiple different components, whereas you can't inherit from multiple different classes. And it's much easier to sort of compose a selection of different components together to get a huge amount of functionality in a small amount of code. Also, they're much easier to mock in tests, and better testable code is better code. So we're going to try and identify a payment to extract, and there's various different things that you might want to extract from a view controller and various ways of identifying what you're going to start with. So I'd suggest that some of the best candidates are things that seem to be cropping up again and again in view controllers. Maybe it's user interactions, maybe it's some kind of interfacing with a database or an API. It seems to be cropping up in half a dozen different view controllers. Wouldn't it be great to extract that out? Or maybe you just want to look at what you're starting to work on. You're going to start to work on this new feature. There's a lot of that logic that already exists in the view controller. If you can extract that out first, then it helps you to build that feature. And now you've got this concurrent building a new feature and making the code cleaner at the same time, which is awesome. Maybe there's a part of the view controller that's causing you so much pain. Like you've had to revisit this code again and again. It's really delicate. You don't totally understand it. Maybe tackling that is going to give you the most benefit. A few examples might be, user interactions, database storage integration, or page navigation. All of this stuff maybe shouldn't exist in your view controller. Once you've identified which bit you're going to extract, you're going to want to come up with a really cool name for it. Come up with a name for this component that's going to help grow this architecture organically. Maybe you want to try looking to the industry for names that already exist for similar functionality of classes. Maybe extract them from a lot of these architectures, like interactor, presenter, coordinator, view model. When you extract it, you're going to want to inject this component into the initializer. The reason for that is it decouples the implementation of your view controller from that class, meaning you can pass in different implementations, and also makes it easier to test. Does your logic have dependencies? So if the view controller uses a lot of other classes, then the component may also need the same dependencies. Think about, can you instantiate this component with some of those values? Maybe actually your component's going to need to rely on some of the functionality that exists in UI view controller, and so maybe using the delegate is easy. Or if it's just something like a completion, maybe it's simple, maybe using a closure would make a nicer interface. So this is starting to get a bit complicated. Let's just see this in action. Here's a view controller that's a mess. In this view controller, you can see it's using an API singleton to load some data. It's doing some view controlling, which is, I guess, what we want, reloading the table view, starting animation on activity indicator. It's also using a storage there and saving data in the database, and it's also aware of the next view controller that's coming up when you press a particular row in your table view. We're going to have a go at extracting this, and what I've decided to extract from this is all of the business logic. And I'm going to call that class a presenter, because it's something that's used by other architectures. So here's like my sort of skeleton for the presenter that I'm going to start moving data into. I've already put a delegate in there, because I know particularly from this like page navigation at the bottom, I'm going to need to access some of the UI kit methods in the view controller. So our delegate is going to conform to UI view controller. Now, something that's really easy to move out is the save user data. You can see it's accessing the API and the storage. This isn't stuff that should be in a view controller. So I can move that across super easily. The next bit I can move across quite easily is this like page navigation. It would be nice if, actually the view controller wasn't making any decisions about where it should be going next. That's really easy to move out, and because our delegate already conforms to our view controller, we can use the delegate to get its navigation controller to push the next view controller. The next bit's a bit complicated. This view did appear chunk of code that's loading some data from the API and reloading the table view. This is a bit trickier because reloading the table view is a responsibility that we do want from our view controller. However, loading it from the API, that's not something. So to do that, we're going to have to introduce a delegate method. This delegate method will let us call back to our view controller after this load data has completed, and then the view controller can take back control and reload that table view. Now we can move that logic quite easily. Now we can implement an extension of our view controller to conform to that delegate and move the bit of logic that is supposed to stay in the view controller in there. Now we've isolated just the bit that we want to remove, and that can move across, and we can call our delegate to pass back control to the view controller. The only thing to do now is to inject our new fancy presenter class into the view controller and call it here. Once you've extracted a component and you've got everything out of your view controller that you wanted, you're going to rinse and repeat. This means go to your other view controllers, see if you can find the same patterns, the same sort of common mistakes, and extract them into another presenter class. You now slowly are growing your own architecture and cleaning your view controllers at the same time. So the next thing I want to talk about is singletons. So what is a singleton? A singleton is a design pattern that enforces that only one instance of a particular class is allowed to exist. It can be really useful when used correctly, but unfortunately it's one of those things that is often not used correctly. And one of the reasons for that is because of its global access. Often singletons are used for the sake of creating global variables and global logic. And you end up with something that looks a bit like this, where so much of your code is reaching up and grabbing at that singleton. And this is a problem, but why is it a problem? Well, for one, testability. If you've got a singleton inside your code, then your code sort of is breaking a capsulation. It's really hard to tell from the outside of that class how much logic is going on because it's reaching out to some global functionality. Also, it's this shared mutable state, which means that some logic on the far side over there can be interacting with your singleton, which affects some logic all the way down here. You end up with this spaghetti mess. So, like view controllers, we're going to try and break them down and maybe remove some. If we have a look back at our presenter, you can see that we were using an API singleton and a storage singleton. Let's try and break that out. It's really hard to tell from the public interface of this presenter that it's even using an API, and it's also incredibly hard to test because if you ever try to call these methods in a test, it's going to be using a real network and a real database, and that's going to be really slow and have negative side effects. So the first thing I suggest doing to break it down singletons is by removing their global access. Once you've removed their global access, it makes them so much harder to use, and that makes it less desirable to try and use. Of course, once you've removed the global access, you're then going to have to go through your entire code base and inject those classes in. And this kind of gives you a really good outline of exactly how many places this code is being used. You can also now see from the initializer and from the properties exactly what this class depends on. So you've got a clearer understanding of its dependencies. There's going to be some classes which just shouldn't have access to the singleton in the first place. Here's an example of a user picture cell. Now, this is a view. Views are responsible for displaying content, but this view is actually able to do a database read to get the user picture that it's displaying. It would make much more sense if we just injected that in. By removing the use of the singleton from this class, of course, we're going to have to use that at a more appropriate place higher up in the sort of call stack and higher up in the levels of abstraction. Next, I think the way to reduce the use of this singleton once you've got it injected into 100 different places in your code is to try and make it less useful by shrinking out some of the functionality that shouldn't be in there. Often, because singletons have this global access, it becomes a really convenient place to put logic that you're having to repeat across your code. In this example, we've got a presenter that's displaying some kind of birthday date, and it needs to display it as a string. And for some reason, we're not using the system locale, and the user is able to choose their preferred locale, and we're saving that to some storage. And because date formatting in the user's preferred locale is something that we're doing again and again across our code base, some smart fellow decided it was a great idea to just put that date string formatting in the storage class. The issue is the storage class isn't really responsible for date formatting, and it's taking up too many responsibilities. And now things like this birthday presenter thinks that it's a great idea to reach into the singleton for the sake of that. If we extract that method out into a component, then the component can just take the required resource that it needs, which is just the locale. There's no need to use the singleton. And our birthday presenter can just create this component and use it directly. Now the use of the singleton is pushed up again, higher up into the call stack at a higher level of abstraction, somewhere more appropriate. Potentially, you have something like a presenter factory that is responsible for collecting all of the relevant data needed to instantiate your presenters. That's a much more appropriate use of a storage class. So I've talked a lot about testing already, but yeah, one thing that you're going to need to do is start introducing unit tests if there's a large part of your code that doesn't have them already. And again, I'm referring to this book. It's a great book, honestly. So Michael Feathers defines his code as legacy code as code without tests. And he says, with tests, we can change the behavior of our code quickly and verifiably. Without them, we really don't know if our code is getting any better or worse. Thankfully, everything we've done so far is going to help your code become more testable. For example, taking the logic from the view controller removes your dependency on UIKit and allows you to test just the logic only. It also allows you to make assertions against raw data types like strings and ints and dates instead of UI views and UI labels, which is much more difficult. Isolating our responsibility in our classes means that there's fewer pathways through our code. This means that you can have fewer test cases to cover your code. And it's much easier to reason about. When we're extracting singletons, we're making tests a lot more isolated. Now there's no shared mutable state that can change as part of one test, causing a different test to fail. Injecting our dependencies allows us to customize the behavior of those dependencies using stubs. And we're even able to verify how they were interacted with by mocking their behavior. We're going to want to test smaller components. By breaking large classes into smaller components, it's going to make the job of testing it much, much easier. It limits the number of scopes of things to test. Fewer possibilities makes it easier to cover all of the cases. Fewer dependencies to mock as well. If you've got a small component, it's much easier to see exactly what it depends on and write mocks for those as you're testing it. As you break out each component, you can write it in a test-driven development way. Perhaps instead of trying to tackle testing this huge class that has so much complex logic, maybe it's easier to write tests for something much smaller that you haven't written yet, and then slowly move the logic out into that new class and be sure that it's fully tested. Finally, you can write some integration tests to cover the behavior of a collection of different components. So you don't need to worry about not having one test that covers a huge amount of code as your pathway. Your unit tests can just cover these small components, and you can later write integration tests that tests the interaction between these components at a slightly higher level of abstraction. So let's have a look back at this user data presenter. This code is now a lot easier to test because we're injecting the API and storage dependencies. The way we're going to do that is we're going to change the API and storage to a protocol. By changing it to a protocol, our implementation of user data presenter no longer has any dependency on the implementation of the API and the storage. Now we can write sort of test fakes to be able to verify exactly how these classes are being used. So let's go ahead and do that. I've called my test fakes an API spy and a storage fake. My spy has the ability to record the way it's being used so that I can later make assertions on it. And my storage fake is going to pretend to work like a normal storage class, but not actually write to the disk, so it's saving a lot of time in our tests. Now we can write the tests really easily. You can see I've created my system under test, the user data presenter, with our spy and storage fake. And writing the test is as easy as making assertions on the spying properties that I've added to the API spy. And we can even simulate that the API completed by calling the completion handler that was passed, and then we can make an assertion that the storage now contains this new user data. A quick note on legacy tests. So legacy tests are huge, long tests that are probably testing legacy code that are really hard to change themselves and causing more pain than they are good. Maybe you're trying to change some functionality, but every time you do, it's causing a nightmare because you've got 100 tests testing the same thing through different pathways, and it's become very brittle and inflexible. Sometimes tests are the legacy code themselves. If you treat your tests like any other code, it says we should be extracting components from them, breaking them down, making them smaller and simpler to understand. Don't be afraid to rewrite tests that are not adding any value. Maybe what you're going to do, like I said before, is write some tests for a smaller component that's much easier to write, and then extract the logic from your monolithic classes into that component. When you do that, you're using a test-driven development, which has all kinds of different advantages as well. So finally, I want to talk about introducing good habits. So clean code inspires clean code. If every time you work on your code, you're making something that's easy to read, easy to understand, that is a joy to use, then that's going to inspire the rest of your team and yourself to continue writing nice code around it. No one wants to start adding code that's going to cause complications to a class that seems so nice already. Bob Martin says that you should leave your code better than you found it, and he calls that the Boy Scout rule. Swift is awesome. Swift is an expressive and safe language. So we're trying to pay attention to the small details in our code, and Swift allows us to do that in a really compile-safe way. There's so many features of Swift that means that your code has to work in a particular way. When you use these features, it makes it really clear to the reader exactly how your code is working because it's enforced by the compiler. There's no way that it could be doing something different. Use code reviews to ensure that your entire team is adhering to the same high standard. Make sure that everyone is doing this. So I'm going to go through a few examples, and these seem super obvious, but they're things that you'll come across again and again in legacy code. You should use magic variables. What's this 16 doing? It's really hard to understand. We're just adding 16? Like, why are we doing that? If we name it bottom spacing, suddenly it's so much clearer. Okay, that 16 is adding a bit of a gap to the bottom of our view. Just that makes total sense. Using guard over if. Guard is so much stricter than if because it forces you to return. When I'm reading this code, there's no compile-safe way to ensure that all of the logic happens within the if statement. Whereas when I use a guard statement, I'm forced to return if those conditions fail. Also, it means that I'm not tabbing all of my code out again and again and again. Something that I see often is enums with associated values, often you end up with repeated fields in all of your different enum cases. For example, in this update error, you might have a friendly description, which is applicable to all of the cases. And you may have even written an extension to try and extract that more easily, because it becomes a nightmare to have to switch every time. Well, a better way of doing this would be to just wrap it. This is so much cleaner, forces every case to have that property, because if I now add a new case, the update error that uses that error type will also still have a friendly description. Optionals, I think, are an overused feature in Swift. You end up using optionals often when it's just being used to make the code compile. A couple of examples of this are maybe when you're parsing data out of a dictionary, because a lot of it comes out as optionals, we end up just setting up properties to optional to match that. But that means that you're changing the actual definition of what this class is. It's not really possible to have a user that doesn't have a name or doesn't have a date of birth, but this code kind of implies that it does. What we really want to do is make assertions on that, and maybe the user details fails to parse and returns nil instead. Now that those properties aren't optional, it's so much easier to work with. Another time I see optionals used is when we're capturing self weakly within an escaping closure. When we do this, you end up with functions that return optionals because you've used optional chaining. Your properties, you have to pass optionally into those functions because you don't have access to yourself strongly. And then you end up having to do loads of unwraps that are unnecessary and maybe even call fatal errors in order to sort of give some description that that wasn't supposed to ever be nil. And obviously, there's a really simple way of fixing that, and that's just getting a strong reference to yourself before you do that. This code is also safer because your instance of the class can't go out of memory halfway through executing that code, leaving your data in an inconsistent state. And of course, there's like many other ways in Swift that you can make your code more strongly expressive using all of the different features. So make sure you do code reviews to pick up on all of those things. So I just want to summarize. I want you guys to get excited about talking about code that's causing you pain. Tackling code that's causing you pain, not just talking about it. Tackle it. Consider refactoring existing code over starting again. Find large classes and break them into smaller components. Reduce your use of singletons. Inject your dependencies to make it much easier to test. Consider untested code to be legacy code. And always leave your code base better than you found it. That's it for my talk. Thank you very much.
So we have time for a few questions. If you could raise your hand, I can bring a mic to you.
So I have a question about dependency injection.
Sure.
So we've been doing this, we've using swinject to inject dependencies.
Yeah.
But if we don't want to use swinject, what are the alternatives?
So dependency injection is a really complicated topic, and Swift doesn't have any support for any dependency injection frameworks. Other languages have things like Dagger, which can inject dependencies essentially by wrapping them in contexts that are only created at the moments that they're needed. Sometimes you can end up with a lot of different dependencies being passed into the initializer, and that's really frustrating and can sometimes be more of a burden. So I recommend maybe wrapping those dependencies in these context objects in a similar way to how these frameworks actually work, and then you can just initialize your classes with a context object that contains those dependencies, and just make sure that you're only creating these contexts in situations where all of those dependencies can exist. Does that answer your question? Yeah. Awesome.
Anybody else?
Great talk. Thanks very much.
Thank you.
I have a question about like when you decide to. It's about the difference between when you want to when you're when you're deciding like a new pattern that you have in your team,
Sure.
how do you kind of decide, like you gave an example in the talk of, oh, we want to just remove global access to the singleton. So we'll just refactor the entire code base.
Yeah.
Versus kind of doing that organically. How do you make those decisions of like like how do we kind of roll this change out? Because we struggle with that a lot. Like, do we do this all right now, or do we try and like iterate towards that? And then you kind of end up with a code base that's in kind of old, new,
Yeah.
like version, new.
I think the best way to make that decision is whether it's possible to do in one chunk. Maybe refactoring this is going to take weeks, and that's going to mean that in those weeks you can't really do any other development work, and that could be a pain. Maybe your singleton's being used in 100 places across the code base, and removing global access might take an hour to solve by passing it down everywhere, and at least then you've made one step and you've completed it in a short period of time. So I think about the amount of time it's going to take, and if it's going to take any more than sort of one chunk of work that you're sat down doing, then you should think about trying to do it incrementally. For the example of removing the global access to the singleton, you can start by actually injecting it, and then once you've finished injecting it into all of your classes, then you can finally delete that. But yeah, I guess you just have to do it with a lot of intention, because otherwise these things can always end up half done and can even become confusing when you're looking at other parts of the code base that don't have that refactor already done.
You talked about many options what to do with the code base, but what would be the only one thing you would do when you would see new code base which is not so great?
Start writing tests.
Other questions? All right, let's thank our speaker again.
Great. Thank you very much, everyone.